Hey everybody, this is Larry. This is day 8th of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Pascal's triangle. Actually, I think I talked about Pascal's triangle not that long ago. Maybe it was a week ago or something like this. The one with the number of paths from the upper corner to the lower right or something like this. So yeah, I mean, I don't think I have to say much. I mean, I think it's a very good introduction to dynamic programming, and in this case, they even have the visualization and telling you basically what to do, right? And yeah, and it's easy for that reason because they tell you what to do. You don't have to think about it, and yeah. Pascal's triangle comes up a lot in binomial e things, and that's fine as well. Actually, I think it was on like what was it like a difficult Q4 maybe last week or maybe the week before, something like this, right? So definitely, it comes up in random places, but also you wouldn't necessarily need to know Pascal's triangle specifically. You just think about it as n choose r or something like this, right? Right, combinatorics and just mathematical stuff. But it is kind of an illustration of how everything kind of falls together. So it's kind of cool. Without further ado, then let's just do the problem. Yeah, number of rows is 30. So one cute thing to note is that the sum of the nth row is going to be 2 to the n, right? So if you kind of look at this even, and you can kind of see why, because for every cell, you're adding, for every cell in the previous row, it contributes to two different like it splits and it gets added twice, right? So because of that, you can see that it doubles every time. So that's one way to do it. Of course, you go just add it up and you could do the math. And it also means that the sum of n choose r for all r's or r's from 1 to n is also 2 to the n. So fun trivia. But it doesn't really come up super much, I don't think. But it kind of lets you do a bound on something like for example, if you have to choose 30 choose 5 or something, and you don't know that you're gonna need long or not, well, you don't need long because the sum of all the numbers is going to be 2 to 30, right? For 30 being the n. So that's like some things that might come into play. And for this particular problem, I looked at this because then now I know that I don't have to do long, because on the last row, the biggest thing is going to be 30 choose 15, and you could actually even just Google it. Or at least that's what I'm doing. And it's going to be 155 million, which is, you don't have to choose another integer, 64-bit integer when I say long. Anyway, let's get started then. Right. Numbers, is it? Yeah. So current row is equal to and then for each number in previous row, maybe this is a little bit yucky to write. Let's see what this is for. I'm definitely writing today in a really funky way, just kind of as practice to, kind of just as practice, I suppose. Oh no, it's just a good idea, to be honest, but we'll see. And I think I'm off by 1, but that's fine, right? I think I'm off by 1. I'm doing an extra row, but I just want to see it real quick, because clicking 1 is pretty quickly. Okay, so I mean, n is also just wrong. Oh, because of the bounds? Whoops. That's not right. What I meant is... yeah, okay, I'll just do it like a normal person. I don't know. I mean, I know what's wrong with this, but because I think I'm treating the corner, I'm iterating it, because if I did it that way, I'm supposed to actually iterate on the diagonals, or diagonal given this illustration, but I'm not, so it's a little bit confusing. And I think I just wanted to show off, but when you fail of showing off. That's just sad. So yeah. Yeah, something like this would be fine, right? And this kind of misses one, and also a one in the end, and I think that's it. Like I did know that's the off by one that I said originally. And of course, why not choose a big number for testing? We already got the small number for testing, so yeah, let's give it a minute. Of course, this is going to be n squared, where n is this, but remember that, as I always try to be pedantic on these videos, n is not the input size. The number of bits is the input size, and the number of bits, it's going to be 2 to this number. Or sorry, the other way around, log of this number. So this number is represented is 2 to the n, where n is the number of input bits, and then you have that square. It's going to be 2 to the 2n, right? Yeah. So the reason why I say that is because if you say this is n, you say this is n squared. It's very easy to get a little bit sloppy and say this is quadratic, which it is not. It is 2 to the n, or 2 to the 2n even. So yeah, unless I messed that up. Maybe it's 2 to the n squared? No, it's 2 to the n times 2 to the n, which is 2 to the 2n, right? Yeah, that's all I have for this one. Let me know what you think. And yeah, stay good, I think today there's a premium problem, so definitely stay tuned for that one. Even if you don't have premium, so we could kind of just go over problems together. Yeah, but otherwise, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.